Hello and welcome to today's chemistry class. Have you ever wondered what makes water molecules stick together so strongly, or why ice floats on water? Well, the answer lies in something called hydrogen bonding. Imagine this: when hydrogen is bonded with highly electronegative atoms like oxygen, fluorine, or nitrogen, it forms a bond that's much weaker than a covalent bond but still significantly influences the physical properties of substances. For example, in hydrogen fluoride, the hydrogen atom is bonded to fluorine. But due to fluorine's strong electronegativity, it pulls the shared electrons closer, leaving the hydrogen atom with a partial positive charge. This makes the hydrogen atom weakly attracted to the fluorine atom of another HF molecule. This attraction forms what we call a hydrogen bond, which is represented by a dotted line. That's how we show this weaker bond compared to the solid line of a covalent bond. So, hydrogen bonding is essentially the attractive force between a hydrogen atom bonded to an electronegative atom and another electronegative atom from a different molecule.
Let's break down the formation of a hydrogen bond. When hydrogen is bonded with an electronegative atom like fluorine or oxygen, the shared electron pair is drawn towards the electronegative atom, making the hydrogen atom more electropositive. This creates a partial positive charge on the hydrogen atom and a partial negative charge on the electronegative atom. Now, when another molecule comes close, the partially positive hydrogen is attracted to the partially negative electronegative atom, and that's when the hydrogen bond forms. This bond forms between two molecules, linking them together with this attractive force. There are two main types of hydrogen bonds: intermolecular hydrogen bonds and intramolecular hydrogen bonds. In intermolecular hydrogen bonds, the hydrogen bond forms between different molecules. A classic example is the hydrogen bond between water molecules or even in hydrogen fluoride molecules. These bonds are responsible for water's high boiling point and its unusual properties. On the other hand, intramolecular hydrogen bonds form within the same molecule. A great example of this is in O-nitrophenol, where the hydrogen atom forms a bond between two oxygen atoms within the same molecule. These types of bonds play a critical role in stabilizing the structures of larger molecules like proteins. Now, let's explore how hydrogen bonds affect the properties of substances. Take water, for example. Due to hydrogen bonding, water has an unusually high boiling point for such a small molecule. If you think about it, this is why it takes more energy to boil water compared to other liquids. The strength of hydrogen bonds is also influenced by the physical state of the substance. In the solid state, hydrogen bonds are strong, which is why ice floats on water. The structure of ice is held together by hydrogen bonds, which form an open, less dense arrangement. But in the gaseous state, hydrogen bonds are much weaker. This is why water vapor, or steam, doesn't exhibit the same bonding strength. Let's get a little deeper into how these hydrogen bonds actually form. Picture this. As the hydrogen atom bonds with an electronegative atom, like oxygen or fluorine, the electron pair in the covalent bond is pulled towards the electronegative atom. This results in the hydrogen atom acquiring a partial positive charge, while the electronegative atom takes on a partial negative charge. When a nearby molecule with an electronegative atom approaches, the Hd plus of one molecule is attracted to the X data of another molecule, forming the hydrogen bond. This bond can be visualized as a dotted line between the molecules. The strength of this bond depends on the size of the electronegative atom and the distance between the molecules. Let's quickly recap what we've learned about hydrogen bonding. This unique bond forms when hydrogen, attached to a highly electronegative atom like oxygen, nitrogen, or fluorine, creates a weak yet significant force with another electronegative atom. These hydrogen bonds affect everything from water's high boiling point to the structure of proteins in our body. They play an essential role in many chemical processes and have a powerful impact on the physical properties of compounds. So, to sum up, hydrogen bonding isn't just an abstract idea. It's the force that holds water molecules together, stabilizes the structure of DNA, and even plays a role in the behavior of substances like alcohol. I hope you now have a deeper understanding of how hydrogen bonds shape the world around us. Catch you in the next class with more fascinating chemistry.